Good afternoon, everyone. You've made it this far. It's been a very packed day. We're going to focus on something a little bit different from what you've been hearing about previously. We're going to be talking about infrastructure, but we're going to start the journey in an interesting place in Italy and around the contribution of Italian scientists to quantum physics, how that then turns into practical systems, how they are used on-premise, and then how they integrate with other modalities of compute, like classical HPC. So, with that said, first of all, Ugo, could you introduce yourself to the audience, please?
Thank you, Richard. Good afternoon. First of all, I have to apologize because I do not belong to the real world, but I'm academic, and also of the worst kind, I'm a theoretical physicist.
It's better than being a chemist.
That said, my background is in theoretical physics. I'm professor theoretical physics, Como, and in another bunch of universities around the world. And in recent time, when computers start to have the word quantum attached to them, and when this become a little bit more close to reality, to use the word that everyone has used here a lot, I become involved in that, establishing the Q Alliance last October in Como. You were there. And also I'm consultant for the Italian government for that.
Excellent. That's great. And Orkun, over to you. Could you introduce yourself, please?
Yes, thank you for the invitation and introduction. My name is Orkun Schensabat. I'm a physicist. I've been using D-Wave Advantage since 2022 for research. And most importantly, I'm from Jülich Supercomputing Center. There I focus on cross-platform benchmarking. What's more interesting is what Jülich Supercomputing Center does. And back more than a decade ago, we already saw the potential of quantum computing. And that is why Professor Christo Michielsen, who's now the director of Jülich Supercomputing Center, already devised the quantum computing strategy more than a decade ago. And this was very successful because now we are the home of 5 highly distinct quantum computing platforms. They are provisioned in our Jülich Unified Infrastructure for Quantum Computing. And first and foremost, of course, D-Wave's Advantage 2 model.
Excellent. Thanks for those introductions. And so maybe I can turn back to you, Ugo. And I've got a burning question. Everywhere I go, I find Italian physicists working in quantum computing. Why is that?
So there are good reasons and bad reasons for that. I will skip all the bad reasons.
Perfect.
Maybe I take just one reason, which is my interpretation of a particular Italian way to go do the science, is that we study Latin in a school. And this is a very good exercise for someone who wants to become scientist, because you need to deeply understand the structure of the language, not only the meaning of a statement. Apart from that, Italian, let's say, heritage is very strong, either in Italy or in the United States. Is the heritage of one person, which is Enrico Fermi, which is among the founders of quantum mechanics, the one who was more close to reality. His influence is so deeply embedded in physics that he shaped also the language. Fermions are the particles which we are made of.
We're all made of fermions.
We are made of fermions. Yes. So I cannot conceive a most glorious way to have an heritage and remain in the history. So this is, I think, has shaped very much Italian science, also US science, as you know. Enrico Fermi was in the Manhattan Project. The Enrico Fermi Laboratory in Chicago is one of the most important centers in the US.
Excellent. And how does that connect then? So from the science and the theory and the quantum mechanics, how does that connect through to quantum computers and systems that we see in operation today?
That's precisely because, as we heard today, building a quantum computer is not a problem of engineering. You have to deeply understand what you are doing and deep understand the way you do it. That's why I'm back to the person of Enrico Fermi, which among the founders of quantum mechanics is the one who know how to put the hands on. Indeed, he was the first to switch on the nuclear pile in Chicago.
Got it. And from your perspective, Orkan, if you look at today's HPC, QC, kind of heterogeneous architectures, do you feel a connection from those practical systems back to the theory as a physicist?
This is actually a really great question, because this leads us to another Feynman quote. He said, "Experiment is the sole judge of scientific truth." But experiment is not enough. We also need theory, because else we don't know why things happen, and we can't predict the outcomes of experiments. But what if experiments, what if they show results that we do not expect? Then we need computing. We need computational physics to verify what we see, because it could be a bias. It could be our instruments not being accurate enough. It could be our theories and models needing adjustment. Maybe we discovered new physics, but if we can mimic what we observe on a digital twin by simulation, then we can verify what's actually happening.
Got it. So it's kind of forming a triangle of an interplay between... Yeah, got it. Okay. And then maybe just finally on this piece, Ugo, next year there's a bicentenary of Volta. That's a very important milestone. How does Volta connect back to quantum compute?
So my involvement in this story is precisely because next year we will have the bicentenary celebration of Alessandro Volta in Como, in Rome, and everywhere in Italy, and maybe in Paris and in London even. Because as you know, the pile was invented in Como, but it was announced to the world in London.
So the battery was first shown here, yeah.
The name in Italian is la pila.
La pila, sì.
Pila, pile, and then now we call it battery. It was announced to the Royal Society, with the letter of the Royal Society, by Alessandro Volta. And Alessandro Volta was a recipientary of the Copley Medal, which was the Nobel Prize at the time. And this is an interesting point, because also it tells you about the interaction between science and techniques, or technology, as we say today. So science was founded. Science is an European invention, because techniques of Chinese and pre-Columbian were maybe better than European technology at the time. But after the invention of science, nothing happened for more or less 2 centuries. In the shape of Europe and the shape of the world did not change very much till the discovery of the battery by Alessandro Volta. That changed everything, and we enter in the electricity era, which we are living today, in which we transform electricity into thoughts by artificial intelligence
and information,
or whatever. So this is one relation, and the other one, maybe you know that the announcement to the world of the Copenhagen interpretation of quantum mechanics has been done in Como, celebrating Alessandro Volta. Niels Bohr was there, and there announced for the first time the interpretation of Copenhagen.
And that was at the centenary.
Centenary, yes.
So that was 100 years ago.
Exactly.
And here we are 100 years later.
Yeah, and the aim is to celebrate Alessandro Volta in establishing in Como a center, Centro Nazionale Volta, which I'm supposed to direct somehow, in which D-Wave is involved, since we are proud customers of a D-Wave Advantage computer. to celebrate the bicentenary.
Excellent. And maybe we could talk a little bit more about Q Alliance now. And, I was there in October in Como. We're proud to be a founder member of Q Alliance, but could you share some of the objectives and where we are?
So there are several layers in this initiative to celebrate Alessandro Volta, which are intersecting somehow, and this co-alliance is supporting this let's say public initiative. Co-alliance is a private initiative. They are the owner of the computer, providing the Centro Nazionale Volta. D-Wave is a strategic partner of that, of course. As you know, other industries are joining, many universities from Europe, many institutions. This is an open, let's say, laboratory, yep. And will be not only virtual, we will have a very beautiful historical villa in Como as the headquarters, yep. While the computer is in Switzerland.
Yeah. And I think it was touched on earlier as well. It's so important to be educating the next generation and building that quantum-ready workforce.
Yeah, that's the main yeah. Let's say, main aim is to provide, let's say, environment in which the young generation can be used, start thinking, put hands on immediately, not waiting for tomorrow.
That's great, and that's one of the messages that came out earlier from the commercial optimization is don't wait, get going. And it's the same from an education perspective. And Orkun, if we look to Germany and more broadly in Europe, what do you see from a kind of European ecosystem development, and what are the kind of German equivalents of what's happening in Italy?
I don't know if there's one single equivalent that directly compares to Q Alliance. It's its own thing. We do have distributed over different initiatives what Q Alliance has. I would say it's something that will help Italy because it will create a bit of a national hub. It's what we observed in Jülich. Because it will give Italy local and sovereign capabilities, and it will introduce a talent pipeline, so to speak. If we didn't have on-premise systems in Jülich, I am not sure if I would be sitting here right now. Maybe I would be sitting in a different room, I don't know. And all this will have an economic impact on Italy, that much is sure. About the importance, I don't think I'm really in a position to judge that. However, my personal opinion is that we see many national initiatives, which I think is great, because the skepticism of quantum is getting lower and lower, and we're seeing other national initiatives. What I hope is that these align and complement each other into a European federated strategy, an overall strategy, because I think Europe needs to work together to keep up with the US or with China, for instance.
Yeah, and as Alan was saying too, that collaboration globally, that's how we move this forward. And so, we're very eager to see that posture being adopted, let's say. Now, let's get a bit more practical. We're here to talk about on-premise systems. It's been a fascinating journey through a lot of adjacent topics, but in late 2025, as part of the Como and the Q Alliance announcement, we also announced the intention to have a system hosted in support of the Q Alliance initiative. What do you think that will mean for Italian academics and researchers going forward?
Yes, before answering this question, I forgot to say, very important, that Q Alliance is as a very important scientific council. So in the scientific council, just to name few, we have Hidetoshi Nishimori, which you know very well, because he helped to develop the D-Wave computer. We do have Gerhard Toft, Nobel Prize in Physics. We have Alan Kohn, which we will meet next week in Milano, with field medalist, one of the most important mathematicians of the world. And we have Michele Parinello in chemistry, that you know also very well. So we have a scientific council which really we expect to help us in let's say, or in the orientation of, this, of the research of QAlliance. So as you ask me about what it means to have the computer there, then I can share one personal experience, because I'm just to understand better what I'm doing there. I start doing research using the D-Wave computer. I'm writing a paper with 2 students of mine on the diluted easing model, making some experimentation on the D-Wave machine. And now we are near the critical point. So near the critical point, we need to really do the shimming side by side. And this means that we need a lot of time. And so we need to have our machine, not just to wait in a line to...
In the cloud.
That's applied to me, but applied to all the other users of the machine.
And you make a really good point. When we engage in these kind of interactions, and we collaborate very closely, and I think you're working with some of our scientists to assist in that.
We are in contact with Andrew King.
Yep. Great. And Orkun, from your perspective, I mean, ULIC has a rich history of using D-Wave annealing quantum computers in your modular high-performance computing stack. In early 2025, I think the announcement was that you'd actually acquired a system as well. And so what has that meant, to ULIC researchers and your user base to have that system on site alongside Jupiter, which is and remains to this day Europe's only exascale supercomputer? So tell me a little about that.
Yes, so one thing I already mentioned, it draws in intellectual resources and manpower. But some obvious advantages of having it on-premise is lower latency. We saw how fast they can be, and we can't afford 2 round trips around the world with some applications. Data sovereignty can be a matter, but let me be frank, these are not the reasons why Jülich decided on first provisioning D-Wave already many years ago, and now even acquiring our own D-Wave. For us, for our strategy, it's necessary. Because we have, as you said, Jupiter, which is Europe's fastest supercomputer. And when we have such a quantum infrastructure and such HPC capabilities, you need to combine those, integrate one in another, which will enable, hybrid HPC quantum workflows.
Right. And what's been the experience from a reliability and availability perspective with the D-Wave Advantage 2 system?
That's probably the main reason why D-Wave fits that niche so well, both on a software and hardware side. So on a software side, I don't believe we ever had any breaking changes. My pipelines back from 2022, they're continuously integrated. They keep running if I trigger them right now, which is huge for us. We can't, this is one of the biggest time sinks. If every month we have to uncover some breaking changes when software is still experimental and not mature. But on a hardware side, I don't think we ever had an unexpected downtime. I may have missed it, but I'm not aware of any. And the scheduled downtimes are always short.
So it's really from the lab to the data center in a way. And UPC, as the machine is known, has a wonderful home on the ULIC campus. And if you get the opportunity, there's a brilliant video on YouTube of a time lapse of the building of the site and the machine. And it's very informative. So let's just go a little bit deeper in brief on what that integration means between quantum compute and HPC. What are the gotchas? What are the use cases? What's your experience been?
Okay, so we have a lot of expertise at Jülich Supercomputing Center when it comes to HPC. our first HPC system, when that was installed, I think it was 87. I wasn't even born yet. And now we have exascale in Europe. And what we're known for in the HPC community is our modular supercomputing architecture, meaning CPU, GPU, storage, they're all modular. And other HPC centers are looking at us how to do the same thing. And we envision quantum being just one more module there. So our users, using the existing tools, can also allocate some quantum resources in the future. That's the vision. And we need to not only integrate it to HPC, but give the users access. They can't just plug into D-Wave at the lab with a USB cable. That would not be good. And our experiences are quantum simulation. You maybe don't need HPC hybrid workflows for that, because D-Wave is very well equipped in doing that on bare metal. But our main focus is on combinatorial optimization, which is what D-Wave was designed for, and it's basically a quadratic binary optimization solver. And right now, our future focus will be on quantum AI, and we're systematically going through HPC workflows, and we're looking at the entire full-stack chain where we can plug in quantum and see any of the metrics you saw before improve, maybe even at the cost of others. Sometimes we want fast answers, sometimes we want better answers, and that's why it's a deep field of research.
Great, and then maybe in closing, if we think about lessons that both of you have learned, or institutions have learned, in terms of establishing an ecosystem and the Q Alliance. I'd be curious first, Ugo, if you had some thoughts to share with people who wish to build similar capabilities outside of Italy.
By the way, we are in the way of constructing it.
Yes.
Not yet done. We will hopefully next year will be on the operational side. Of course, you have to struggle with many, many appetites. So there are not always friends, but it's an interesting experience building this, and which I'm doing personally for the young generation to be, let's say, on time.
Yep.
So not to wait that the thing exists, but try to build it.
Yep.
And we decide to build it in this particular way, build a place where academia, industry, stakeholders, every potential user can convene.
Yep. Best way of predicting the future is to invent it, so I totally agree with that. And from a HPC center perspective, what lessons would you share with other HPC centers or other folks who are contemplating deploying quantum computers in their infrastructure and on-premise?
I'll try to do one better than just giving you one takeaway right now. You can reach out to us anytime if you're interested in improving your ecosystem or building one, because you do not have to reinvent the wheel. We already did that, and we've been doing that for a decade or two. And we had lots of learnings there. For instance, our applications, you can find them all in our unique benchmark suite. And you do not have to take anyone's word for how good the performance is. We're independent. Come contact us, talk to us. We give about 100 tours every year showing our facilities to anyone. And I hope maybe one or two will join those 100 tours in the future.
But I think, Orkan, you do the majority of those tours, right?
So you'll quite a lot of them, yes.
So you'll get to see Orkan. But we're heading out of time, so I'd like to say a big thank you to our panelists. Please give them a round of applause.
Thank you for having us.